All right, so we basically said that density can be basically something very compacted, whether it be weight or unit area. So like grouping of people. So, and I said again, the units for when something is weight-wise or volume is grams per centimeter cubed, or, and I'm going to write this on there as soon as I can. Well, I can't. And that's pounds per cubic feet. Pounds per cubic feet. So that would be the other one. When you're talking about people, you're talking about people within a square mile. Okay? Remember a while ago I gave you New York City and I said 15 square miles? How did I know square miles? Well, that's what density is measured in, square miles. It can also be information now. 20 years ago, you wouldn't have heard of this. But now, information can be given in gigabytes per square inch. Okay? So, I'm not going to test you on this, but I think the first two are very important for you, unless you're going into computers. The first two are very important because you're talking about grams per cubic centimeter or pounds per cubic foot. That's good information to know. And people per square mile is good information to know, not only for a standardized test, but if you are in some kind of career where you're talking about population, that people per, or count of people per square mile, that means population density. Concentration. How well something is mixed with another. Think of orange juice or Gatorade. All right, Gatorade. I drink this stuff every day. It's hydrate. It's called Hydrate. And it's like a Gatorade, except it's sugar-free. And a lot of people like it real sweet. I do not. I like it kind of weak because when I drink Gatorade, when I was growing up drinking Gatorade, I would mix Gatorade real weak because I don't like the syrup type drink. So that's a concentration. If you like your drink real sweet, then it's a different concentration than somebody that likes it weak. Somebody may want straight up whiskey, where somebody might want whiskey and water, okay? Because they like a different concentration. Same thing here. Concentration of air, concentration of gasoline. Something that we talk about, well, we don't talk about a good bit, but moonshine. When you make moonshine, what comes off is called the heads. That's like 180 proof, and that's not worth anything, so you throw it out. Then you get to the hearts, which is down to 100 proof, and then you get down to the tails, which is about 60 proof. And you mix the tails and the heart together, and you get about 100 proof. That's called the concentration. Blood alcohol level, that's a concentration. So concentration is how something is mixed into another. Again, I don't know why we're going over that in math class. This is more of a science type deal with biology, with population, as well as concentration, but I don't know why we're going over it. But as far as a good word for a standardized test, concentration, mix. A child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment with amoxicillin at a dosage on 30 milligrams per what?
Kilogram.
So the first thing you do is put 30 milligrams over 1 kilogram of body weight. You might want to put body weight on that bottom. You've got a fraction to start with. Divided into doses of every 12 hours. How much amoxicillin should the child be prescribed every 12 hours? Okay? If the medicine is to be taken in a liquid suspension with concentrations of 25 milligrams per milliliter, how much should the child take every 12 hours? Well, first of all, if you've got 30 grams, okay, you got 15 grams, a child weighing 15 grams, 30 milligrams per kilometer, blah, 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 divided into every 12 hours. Okay, first of all, you got to find the dosage and then divide it by 12 hours, right? So let's take our handy-dandy whiteboard. Find the whiteboard. There it is. And let's pull up the whiteboard. And this is this is what you call unit conversions. So you need to write this down and call it unit conversions, because this is something that's very important. Okay? All right, so what I'm going to do is, first thing I'm going to do is I'm going to write down 30 milligrams per 30 milligrams. And I'm going to put of medicine, that M there, so we keep the two straight because they're both weights. Milligrams per kilogram of body weight. Everybody with me? Mm-hmm. Okay, so that means that up here, I'm going to put kilograms up top, because why? Well, you don't want to get rid of the dosage. You don't want to get rid of milligrams because that's the dosage. So 15 kilograms over 1. And what happens to the kilograms? So what's left? Milligrams of medicine is left. So that's what you got to give this kid. So somebody multiply that. That's 30 times 15, which is 450 what? 450 what? Somebody check me. Did I get it right? Milligrams of what?
450.
Medicine. Everybody with me?
Yeah.
Now, what do they say here? Divided into what?
12 hours.
Doses every 12 hours. Why 12, not 24? I guess not during the night, I guess. Divided by 12, somebody give me that. What's 450 divided by 12 hours?
37.5.
37.5 milligrams per what?
Per hour.
Per hour for 12 hours. So that's A. If the medicine is to be taken in a liquid suspension with concentrations of 25 milligrams per milliliter, how much should the child take every 12 hours? Well, here you've got to do 25 milligrams. You're going to have to, how much should the child, you still got to take the milligrams. They're going to cancel out the milliliters. Probably, no, milliliters is going to stay, the milligrams is going to cancel. But we'll go to another board. Let's see if we got A right. Let's see, there we go. Okay, we didn't get A right. Or did we?
That's strange.
Wait a minute.
Wait.
15 times 15. Where did they get 15 times 15? Oh, why did they say the child's 15 milligrams?
It says each dose would be based on half of the total.
No, look at the top. It says, how much did the child weigh? Did I not read the question right?
No, you read it right. I don't know.
A child weighing 15 kilograms has a bacterial ear infection. A physician orders treatment amoxicillin at a dosage based on 30 milligrams per kilogram of body weight, divided into doses every 12 hours.
Maybe it is doing it 24, but it's dividing it in half. Which is still weird.
I don't know what they're doing.
It's only being given in 2 doses every 12 hours instead of once every hour. it's being done every 12 hours.
Well, we should get half the answer. And we're not getting half the answer. We're getting some other answer. The prescribed dosage is 30 milligrams per kilogram of body weight, but because it was given in 2 doses, we're not. See, they didn't say 2 doses. I'm sorry, y'all just have to forgive me. I'm missing something in the question. A child weighing 15 kilograms has a bacterial ear infection. 15 kilograms cancel. What's 450 divided by 24?
18.75.
I don't understand that.
Go down. The hell? I just did.
I don't understand what they're doing.
I don't understand how they're doing this, because if you're given 30 milligrams of per body weight, you should multiply that by the 15, because that's how much. But see what they're doing: 15 milligrams over 1 kilogram. Isn't that what I did?
Mm-hmm.
15 milligram. 15. No, they're not doing that.
You did 30.
Because that's what it calls for.
Yeah.
This is the dosage. Right here. That's the dosage.
Yeah.
That's right there.
For whatever reason, they're dividing the dosage into 2. And that's what I'm trying to figure out, is why they would do that.
Okay, then why did they even give the 30 per? I mean, they shouldn't even get that.
That's what I'm wondering.
This is okay. All right, they're saying that every 12 hours you half this dosage into 15 milligrams per kilogram. This is a dorky question. I don't understand why they did that. Okay, so instead of 30 milligrams per kilogram, since it's 12 hours, I guess we're supposed to automatically know that that'll be 15 milligrams per kilogram. I don't understand that. What's the use in putting it? Why don't they just say 24 hours or whatever? Why are they? I don't know. I guess I'm just not that's why I'm not a nurse. All right, 15 milligrams over 1 kilogram multiplied by, and what do they give us for the
15 kilograms.
he weighs 15 kilograms, then that's going to give us 225. So he should be given 225 milligrams per 12-hour period. Okay, I don't agree with the way the question is worded. To me, you're reinventing the wheel by doing it their way. It's not a well-written question. All right, now what's the next thing they're going to do? Well, they're going to cancel out. They need to cancel out here it is, and they'll show it how to cancel out right there. Okay, so they're wanting to, and I'm not going to write it like that because they're doing it. You got 225 milligrams over 1. Okay, that's what you need to give the guy, right? 225 milligrams over 1. That's the dosage. But now we got to change it. It said if the medicine is to be taken, if the dosage is to be taken in a liquid suspension, I mean the IV bag, with a concentration of 25 milligrams per milliliter. Okay, so that means that we've got to put milligrams on the bottom per what? 1 milliliter. Okay, and that's going to be, what's going to cancel? The milligrams are going to cancel, and you're should be left with milliliters, because liquid is measured in what? Milliliters. So what's 225 divided by 25?
225.
9 milliliters, which is 9 cc's, basically. I think it's milliliters. Cc and a milliliter is the same thing, isn't it?
Yeah.
Has been a wrong person. That's why I quit nursing school.
That 12 hours, that, maybe if I'm a nurse, that makes sense. To me, you find the dosage and you divide it by 12. To me, that's what you do. But I'm not a nurse, so maybe I killed somebody. I don't know. All right, that's it for that. Thank God. Now let's move to what? What was that? That's this is 3A, right? 3A coming up?
Yes, so we're in 3A. Yeah.
3A, where's 3A? Is that 3A? That's 3A right there. Okay, percentages. Now, this is not going to be a hard section, because percentages, we've already went over them five times over the semester. Okay? 13,000, blah, blah, blah. 2.6 of the newspaper workforce lost their jobs. Okay? So how do you do 2.6 times 13,000? Well, you got to change 2.6% into what? A decimal. So what would that be? 0.026 times 13,000. All right? That's all this section is. Fractions, decimals, and percent. So not a lot of problems there. To describe the change, Citigroup stock fell 15% last week to 44.25. Okay? Now, of course, that would be the Walmart equation. If you wanted to find the original stock, it would be X minus 0.15X is equal to 44.25. So let's write those on the board just so you can recollect what we did way back. Okay, because I know we went over this before. If not, you got it in your pre-algebra class. This right here would be 13,000. Somebody keep me informed of the time. 13,000 times 0.026. And the only thing I like to remind you here is this cannot be used in a calculation. You have to change that to a what? A decimal or a fraction. 2.6 over what? 100, which is 0.026. So that's the only thing really you can use as a decimal. This one is the Walmart equation, which is percentage, I'm sorry. Hold on. Is X plus or minus percentage X is equal to the total. Now read the question. Is this the original or is this the total at the end?
Total at the end.
It goes right here, 44.25. Equals, and we know it's minus. Fail means minus. And then X, 1X minus 0.15X is equal to 0.85X is equal to 44.25. Somebody take 44.25 and divide it by 0.85. 52.05. So the original was 52.05. And again, these are things that you should have done in pre-algebra or 101 or 102.
Where'd you get the 0.85?
What's 1 minus 0.15?
Okay, that's what I was trying to think.
That's the question that everybody asks. I don't know why people ask that. That is the most asked question in all of algebra is when I go from this point to this point, people say, where'd you get that 0.85? 1 minus 15 cents. What's a dollar minus 15 cents? 85 cents. But that's the question that's always asked. I'm used to it. For comparisons, let me erase this right here. The advanced battery lasts 125% longer than the standard one, but costs 200% more. Now, really, there's not a question there because they don't really give you enough information. I don't think they do. But they're just describing how something can be longer and cost more. Okay? So they're just showing you 3 ways of using percentages. An opinion poll finds that 35% of blah, blah, blah people surveyed, the president is doing a good job. Racist. How many said the president is doing a good job? Well, 0.35 times what? Times 1069.
375.
375 because there is no 0.5 people. 375. So that's what kind of questions these are. So if you miss these questions, you should not tell what? Anybody.
Anybody.
Exactly. Now they rounded down. I would round up because in people, and this is please let me reiterate, when you're talking about surveys or you're talking about statistics or probability, when it's talking about people, you always round up. Okay? In mathematics, the answer would be 374. In statistics, it would be 375. All right? Okay, but now if it came out 374 even, then the answer in statistics would be 374. But anything in probability and statistics, anything over 374 turns into what? 375. So 375 is a statistical correct answer. 374 is the mathematical correct answer. What did you say, Ms. Porter?
2 minutes.
Okay, thank you. Let's see what else is left in this section. Absolute and relative change. New minus what? Old. Absolute change. New minus old. Just put change. New minus old. Percentage change is new minus old over what? Old times 100. Okay, so you need to write that down. That's very important. Now, a lot of people say, why is it important? I had a person ask me that before this just change. New minus old. Okay, so if I made $20,000 last year and I'm making $30,000 this year, what kind of change is that? $10,000. Okay, percentage change is equal to new minus old over old multiplied by what? 100 for your percent. So always remember this one especially because this one is something that you use in any kind of business, any kind. Whether you're in the hospital business, medical field, or if you're in the industry, or if you're in engineering, you're always going to get percent change. New minus old over old times 100. There it is. New minus old over old. But y'all, we don't need to be redneck, so we need to say old is reference value. New minus old over old times 100. And that's where we'll stop. Okay?
I use annoying words like that.
To make you sound stupid.